Oh shit. Damn it. I really want to put pressure on those LEDs. Gives a little more space if I'd use the side jaws. Yeah. It might be okay. Just loosen this one up a little bit so it's not so tight. Yeah, that'll work. Yeah, but now I can't get in there. Let's do opposite corners. Why is this not focusing very well? So that should be good. So I'm just going to tack all these guys. Hopefully I'm not overheating the bottom. Nah, it's sinking pretty good. This board should be able to sink some current, some heat pretty good, so not terribly worried about it. I'm worried about not having enough light over here. More. Alright, so I'm probably just gonna put some flux on there. And then just hit this with the iron. Alright, that should be good. Alright. And I will probably clean that up later. I gotta get some better light in here. This is terrible. See, look, I scratched that up. Hopefully it's okay. So, Should I go ahead and do the other one while I got this one out? Well, the other one's still wired up, so clean this up too. This is a fucking mess over here. It's gonna need a higher wattage thing. I need to get this connected. I don't know what kind of connector this is. Yeah, that's gonna be a lot of, I need to, it's almost shorting out though. There we go. Let's get the plastic off there. There we go. It didn't form a nice joint though. Whoa, look at the way that clouded up like that. That's strange. Is it because I mixed? This must be ROHS. Oops. Oopsie doopsie. I probably used leaded solder. Oh well, it'll be alright. It ain't gonna hurt nobody. Alright, now I got a connector on there, and now I can actually run this in parallel mode. I mean, serial mode. I don't have a driver. Well, it's going to be easier to drive this in serial mode because the libraries already exist. So if I can get it working in serial mode, then I'll know the pattern of this display, and then I can look at doing it in parallel if I want to get some faster speed. But for serial mode, you basically just jump your RGB RGB shift registers, and you just jump them to the next one, so that you're just shifting in a single serial stream, and it's just shifting each one out to the next one. And this way you don't have to have separate pins driving 3 separate shift registers for the RGB colors. And this way you can just shift out your red, whatever the order is, red, green, blue, shift it out to the end, then jump it back to the beginning of the next one, and just shift it out in one big stream, one serial stream. So basically you shift you jump the output to the input, and these are just shift registers. They just shift through whatever you send it. I believe it depends on. I think these panels are all the same, so it should just do whatever you send them. It should just shift them on through, and then you're going to control it with your clock and your I forget what the name of the pins are. It's a clock and an enable, and there's like a commit signal. I don't know what it's called, but that's how these work, pretty much. And then each one has a different interlacing. It could be one row. It could be every 1 and 8. It could be 1 and 8 backwards. It could be, some of them are even half, 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 and they're done like that so that when you drive them, it creates an interlacing that creates a faster refresh. But each one is different, so you got to figure out what kind of pattern it's expecting and how it's wired. I don't think anybody's figured out how to look at it and tell how it's wired up. But I mean, the easiest thing to do would be just to send a shift register down, and just to send some clock pulses in a shift in a bit stream, and see what it does. That's the best way to do it. Maybe somebody made a test sketch that we'll test it out. So that's what I plan on doing. It's a little loud with my printer going, but I'm gonna go ahead and work on this panel, P6 panel, LED panel, and see if I can get something going. I soldered this one on because I didn't have one. These panels didn't come with a populated out strip, so I soldered some SMD headers on there. And I just got these in the mail for the power, but I don't have the terminals. It didn't come with the terminals that you use. You know, didn't come with the metal crimps, so I don't know what I'm supposed to do with the shells. Look at some of these other ones I have and see if they'll fit. These are much smaller pin sizes. These pins are huge. I wonder if I have something like this, some kind of Molex connector that's got the same pin headers. These are pretty big. I don't know if those will work. Let me try one of those. I got these ones. I think these are just regular DuPont size though. Get off of there. No, those won't work. Those are too small. While I'm in here, let me see if I have a... How many positions is this? 10? 9. 9 position, huh? I highly doubt I have a 9 position connector. That's a weird size, very weird size. I'm gonna have to make one. Oh, what's that? 1, 2, 3, 4, 5, 6, 7. It's a 7 pin. I wonder if I can use a 7 pin. Wait, is this 8? 1, 2, 3, 4, 5, 6. Oh, I'm sorry, 8. It's an 8 pin. I might actually have... I have a 7 pin, but not an 8 pin. Are you kidding me? Jeez, I swear. Oh, what's that? No, that's a 7 pin also. Why do I have such weird sizes? I guess I could use an no, not on that side, I can't. I will have to cut one. How do I not have the right size? 7. Why do I have odd numbers? 1, 2, 3, 4, 5, 6, 7, 8. Jeez. Could you cut? I guess I could cut one of these down, but then the pins aren't going to stay in there. Oh, this is ridiculous. I can't believe I don't have the right size header. I can make a double using these. Yeah, I guess I could cut these and make a double, but I didn't really want to use DuPont connectors. I was hopefully I could just hoping to use a ribbon cable and just crimp it down in there and use this. Nope. Of all the connectors I have, I don't have that size. In fact, I bet I do have that size, and I bet I used it for another project. And I'm going to need a bit of field of view. This is really only 12 inches by 12 inches. 12 inches by 16 maybe. It's not really good. I mean, you can't see my soldering iron over here, my scope. I'm almost going to need 2 cameras for these kinds of shit. I need an adjustable arm so I can bring that up higher. I don't remember it being zoomed in that far, but maybe because this is closer now because I have a new surface. I cannot believe I don't have an 8-pin connector. Well, that really sucks. I would have ordered some. I assumed I had some. Alright, back to this. I wonder if these, no, these are these are not even close to the right size. No, these are huge. Alright, I'll just leave that on there for now. Maybe I'll get the pins in. Well, I don't know what I'm going to do now. I don't have one of these connectors. I don't have one of these connectors. What I do have, I mean, if I'm going to make a board for here, then I got to wire it, and then I got to wire another connector if I want to make a daughter board for testing. Whereas if I just had the right connectors, I could just plug it in and then make a daughter board. Alright, so I ordered a bunch of 16-pin connectors. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. I ordered a bunch of 16-pin connectors or ribbon cables to deal with that, but I don't feel like waiting to start prototyping on this. And I can always make a board that plugs in there, but then I have to wire all of it. It's going to be just as much work. So I think I could just make a DuPont connector and then plug this other side up to my ESP, and then I won't have to really do anything. And the only problem is I cut these cables up. So even on, I pulled these cables apart so I don't have the right sizes. I only have 7. I don't know why they're all 7. I cut them all into 7. And so I'll have to put another extra 2 on there. But this is the biggest heat shrink I have, doesn't really fit around there. But I have this, and this should fit. In fact, I keep having to go and get this out of my toolbox because I don't have any in my heat shrink container, because it's just, I have a whole roll of it. I should have got a different color than white, but I think they only come in white, red, and blue. So I'm going to put that and keep some of this available for my heat shrink. This is 18650 battery heat shrink. I don't know where to get the nice stuff. This is the cheap plastic crap, but I've seen some that have a really nice matte finish. and I don't know where you get it, but it's basically, this is real cheap, but you know, it's basically this stuff right here. So it has a very high shrink percentage, much more than regular heat shrink. But I think I've seen a nicer style that's actually matte finished, but I don't know where you get that from. So this should fit around here. I'm gonna cut this off, maybe just enough to cover it. These are sewing scissors. I like them because you can just, they don't line up very well, but you don't have to have a giant pair of scissors in your drawer or bench when you need to cut something. Let me move that back. And I really need to center this camera on this bench, but I just don't have the focal distance. I'll have to fix this one day. And this should fit on here. Yeah, that should be perfect. So I'm gonna go ahead and finish making this connector. Hopefully it stays together. So I need a 1, 2, 3, 4, 5, 6, 7. I just need a two pin cable. And there I have some. This is just full of all my cables. I don't need my solder. Put that up. All right, I'm gonna have a hard time keeping track of these wires, but most of these are not no connect, or not no connect, but grounds. You're supposed to connect all the grounds, but I don't think it really matters. I guess I could put these. It's gonna be hard to get over the end. Get in there. I guess I'll put it that way so that's, make sure these are all in there good. I guess I could have 3D printed a container for these. Huh. That would be the best option, is to create clips for 3D print clips that fit on different sizes, that fit, you know, right in there. I guess I could have did that. It wouldn't have took me 5 minutes. I probably would have, well, I don't really have the modeling stuff installed, so it might have taken me a little while to do that. Well, I guess I should band these in the middle too, but I'm not going to worry about it right now. I really want these, I really want this to go like that. Ah, see, look how much it's going to shrink. It's a little too much. See, it didn't do what I wanted to on this side, but it might be okay. Did I put that over the... Oh crap, I did. I put it over... Jeez. How the hell did I do that? I think I might just redo this because that's really not good. Let me see if it's gonna work or not. I mean, I guess that'll work. And I can always tape it up after that. And then see if this will work. Huh. Well, that should work okay. Let's see if I can unplug it without it completely. Not the greatest. But if I can keep these connected and then slip this guy over the rest, and get that, because there's no way I'm going to fit that around. I mean, you can stretch it, but it's just not going to work. So I'm going to just melt that around there. I really want to push it in there. Let's see, it'll start to melt. Damn it. That's the only problem with that heat shrink is it's really thin. Probably have the temperature too high. But that should work. I mean, I'm not going to be unplugging it and plugging it in. I could always super glue it, but I don't want to waste these. So that should work for now. And I only need to put 3 connectors on here, this side, I think. So it should be okay. I guess I could use. So they use electrical tape. It might be a little too thick to get in there. You can use Kapton doesn't really stick very well. So I think this will probably work the best. And then I can just peel these all the way back. And this side will plug into my ESP. Maybe I should put another one of those in here. Around, yeah. Let me put another one of these in. Alright, there's my little cable. I think it'll work for now. I really wish I had the right size cables, but at least this side is a little bit of different colors than this side, so I should be able to keep track of which, which red, orange, yellow is which. Because, they're in 2 different pieces, so that should work. And this should give me enough space to plug this in and work it out. Alright, so that's in there. It's all the way in there. Oh, good thing is this even reaches over here. But so, well, that's going to be a problem. I didn't think about that. Now I can't do it like that. If I'm going to plug the RGBs over, then I'm stuck like that. I guess I can cut that back off. That was probably a bad idea. Or I should have separated the ones I needed out to jump across. That's fine, whatever. I just wanted to keep this together while I'm messing with this, so I don't really screw it up. I'll probably just use a separate jumper cables to go to that one. And I wonder if I should keep this in this. I might keep this in this rig like that, just so I can plug it up and not have to deal with it moving around the bench. Alright, so I have two of these modules I built. These are my little breakout boards. So I did one with female and one with male. This is I have this programmed as I was playing around with this LED control library for the Max, was it 7219, I think, and different forks of that library, and I was customizing it for characters and stuff, and I had a subscriber count set up for that. So, but you know, I guess I could keep the code on here and move it straight to that and use a different ESP. Well, too late now, I already disconnected it. It doesn't really matter. I mean, that's the problem with doing projects, is you have to have, you know, enough to keep your stuff wired up. Like, for example, there's another ESP Node MCU. There's another Node MCU. And I have yet another, well, this is an ESP32 I have wired up to this display. And I don't want to have to redo that again, because, I mean, these damn SPI displays, they take a ton of I/O. And I do not want to have to redo this. So for now, it's going to stay like that. Yeah, and this one's wired up to a SPI display. Is it SPI? No, this is I2C. No, it's SPI because it's got chip select and a blank. So that's this is one of these IPS. Yeah, it's an IPS display. So I was using this for something else, but I left it plugged up to the display so I don't have to rewire that again. And that's what happens. You cannibalize projects that to make other projects, and then you never get back to the one you were working on. So now that I have that, I'm going to put that in my heat shrink. Container. I don't think I need this. Alright, so now I gotta look at the schematic for this and check it out. Oop, and work it out. This is the connecting. This is the pinout. It's not labeled on the panel. You could always guess based on what other panels are. Oops. But I really don't like the way that's grabbing on that chip right there. It might be enough force to push those chips off. and it doesn't actually grab the LEDs, so it's just squeezing the board edges. That's good enough for now, and I can slide it out of the way. It's really the best option, and I still have just enough space to get on my board, mount to my board, and wire it up. So that's what we'll have to do. And then I'll have to flip this over and solder some power wires to it. And problem is I'm gonna have to reference what goes where, so I'll have to maybe print out or draw a map. See if my printer's on. Let's save paper and we'll do two-sided. Now I have a monitor here and a monitor there over my bench, but I haven't hooked them up yet. So, well, I had them hooked up, and then I got to reroute all my wires to my computer so I can use this as a second monitor, and then throw schematics on here. And this one gets hooked up to a Raspberry Pi for other stuff. But we'll make this work. All right, let's try this one more time. So what we got here is, all right, if your input connector has R1 in the top left corner, R1 in the top left corner, okay, that's up, get the arrows up, okay, up and to the right, see, up, right. So, oh, I'm sorry. Yeah, R1, top left corner. So what is this talking about? P in. Oh, that's what you have to connect across? So 1, 2, 3, 4, 5 cables, really? Well, see, I don't know which one. I'm assuming this would be the same. Would this connector over here be the same pin out as this one? I mean, I guess that's safe to assume, right? Well, let's see if this is a standard pinout. This one's got a R1, B1. Let's just translate this right here. This is R1, B1, R2, B2, A, C, clock, oops. CE, clock, is that clock enable? And output enable. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is there 9? What did I do wrong? Oh, that must be O. I did that wrong. Alright, stupid me. Let's just erase that. Well, whatever. I don't really have an eraser. This thing's shot. Alright, so it looks to be about right. R, B, R, B, A, C, clock, O, E. And then on the right side we got G1, ground, G2, ground, B, ground, let, ground. Okay, so this is pretty standard. I'm just gonna write it down so I know, because sometimes these are labeled different things. G1, ground, G2, ground, B, ground, let, ground. And we'll go ahead and just do this. All right, and then do this, and then we'll do up, right, and we'll assume that this is the same. I'm going to assume that the output is the same. It's got an arrow to pin 1, it's got a little notch there, it's got a notch there. I'm assuming that this is exactly the same, right? Because it's supposed to daisy chain. So this one daisy chains to the next one. So the pins would have to be exactly the same. So this is how we wire it to the ESP. Here, STB or lat. So lat A, B, C. We don't have D. We don't have an E, so we must be using, we're not using any of these patterns. POE is OE. Clock, and R1 is the start of our stream. So that's our data in. Data jumps from R2, R1, R2 to R2, G2, G1, B1, B2. So that's the way. So the data runs from R1, out R1, well, I guess R1, yeah. Actually, it flows that way. I did this backwards. In, out. So it really goes a zigzag. So kind of like that. So R1 out to R2, R2 out to G1, G2, G1 out to G2, G2 out to B1. So it's R, G, B, bitstream. So I'm just trying to make myself understand how this works so that I don't get confused. Because when I read all the specs on this, when I read data sheets on these, I was only looking at it in parallel mode. So basically you'd sign a shift register into each one of these. And parallel shift parallelly shift in the bits, and then the A, B, and C is a selector for which I think this is a selector of which column, or not column, but group of bits, maybe? I'm not really sure. Which register? Yeah, so for different patterns, there's more pieces of basically segments of the panel that you're assigning the bits to, where the bit stream's going. From what I understand, that these are bit fields that designate I guess some pattern assignment. And then you have your clock and your output enable. I thought there was what's lat? Lat must be, I'm not really sure. It probably says it all in here. I just didn't read it. Address, yeah, ABC is the address, row scan pattern, and multiplex pattern. So quarter scan, it toggles it, AB, and then maybe it goes BA, whatever the zigzag pattern is. And then straight will be just ABCD, A. Yeah, so ABC is a, okay. Yeah, see, it says it right here. Since we're only, we can therefore jumper wires between input connector and output connector to chain all shift registers together to create one big shift register. This has two advantages: reduce the number of GPI pins, a lot of GPI pins. In fact, you probably couldn't even do this on a ESP8266 without a some kind of MUX or a break, an I/O board, an I/O expander board. And then you can also, since you're using a single data output, you can use the SPI hardware, SPI to drive it. Because you're not driving multiples, you're only driving one data bit stream. And that's what we're doing here. We're chaining P in to P out. Actually, it's not P in to P out. That's what happens on the board. We're chaining P out to P in. And basically the first register is R1, and then R1 out to R2 in. So we're not going to connect any input for R2. Well, how come it's not G1? Yeah, I'm sorry, G1. R2. So why do they put these not next to each other? R1, B1, RGB, RGB. Okay, so it's grouped in like, I see what they did. They grouped these in groups of, they grouped these in quads so that you have, that makes more sense. Okay, so R1, G1, B1, R2, G2, B2, A, B, C. So this is basically hub 75. I cannot write sometimes. That's supposed to be a 5. Jeez. My handwriting's terrible lately. Okay, so you have groups of 4 pins, so it, right, left, right, left. I don't know if that's how you number these connectors or not. Is it 1, 2, 3, 4, 5, 6, 7, 8, or is it down one and down the other? I think it's opposite. I think it zigzags because when you use an IDC connector, it zigzags. Because an IDC connector is in line, and it swaps the pins so that it crimps in row, you know. So it uses different crimps on each side. And maybe I have one to show that. Let's see if you can see that on here. I'll have to look that up, but I'm pretty sure that's how it works. Because, so here you go. When you put the cable in there, see how it staggers? So you essentially wind up with 1, 2, 3, 4, 5, 6. It's actually zigzags. And that might be how these are numbered. One, I don't really know. But maybe if you look at a connector, maybe it'll say what they are. And then this snaps on and crushes your cable. So I was hoping to have one of these that's the right size for this, but I don't. Alright, back to what I was saying. That's my understanding. I could be wrong. I didn't read over the data sheets in a while. It's been a couple weeks. So I guess we can just go ahead and start wiring this up. And I guess I need to print out a... Oh no, it's got the ESP load MCUs on here. So these need to go over here. These need to go to my board. I think I might need to cut this off and strip back these connectors. Because which ones have to go to the second connector? All these. So ESP8266 and 0 goes to PO. No, that should be pretty, that's good enough legend for me. I understand what's going on now. Okay. So, I mean, this whole group right here needs to go to that connector. So I'm probably going to have to cut this off, and yeah, this is not going to work. Sorry, heat shrink. Sorry, heat shrink, I wasted you. Alright, so we're going to look at this like this. This, I'm pretty sure this goes in. Pretty sure it didn't twist. Of course, I can't see it. That could be twisted. Oh, crap. Oh, I might have to pin out that first one. Or go look back in the video and see. That's because my things weren't long enough. Let's, pretty sure it didn't turn. That should be red, yeah. That's red right there. Okay, so we'll put that back on there. So red is R1. So that's convenient. And orange is G1. So I might as well just pull these back. So G1 goes to R2. I'm just gonna have to pull these apart. So this is data in. Data in goes to D7. Okay, D7. And G1 goes to, this is PN, PI. PIG1 goes to R2. R2 is here, so this goes right there. Doesn't feel like it's grabbing really good. This connector's long enough. Jeez, this is gonna be real tight. All right, I got 2 wires connected. Yay! 2 wires connected. We're making progress now, man. Now I see why people build boards, because it's very annoying. Alright, so all these ones right here, we got B1, R2, B2, which is going to be the next 3. The next 3, might as well just separate all these wires. I'll just buy more, you know? Oh well. The next 3 go to, alright, so this is, I'm gonna have to translate this probably, because it's gonna get confusing. Alright, so yellow is B1. We'll just do this. We'll just do a little Y over here, and then we'll do a O, and then we'll do a R. We'll do a R1, and then we'll do a orange 1. Alright, that works. Yellow. And we'll mark them over here too so we can translate it. So we'll do B1 is yellow, B2 is red, G2 is, haven't got to that side yet, and B1, R2 is orange, and then R1 is, I don't know. We'll just do yellow to G2, which is 3. This would be easier if I had a picture of the connector. I need this diagram and a picture of the connector too. Well, we'll just figure it out from here. Yellow goes to G2. G2 is the 3rd one down. Ooh. Yeah, this is gonna be tight. 3. Oh, jeez. I'm gonna get that connected for now. Orange goes to R1, which is the 1st one. And red goes to B2, which is the 4th pin. I really wish these were labeled. I should have printed out a label or some sort to label these. That looks about right to me. Alright, I think that's right so far. Now I gotta go to this side. And this side gets G1 is purple. G1 is, wait, not purple, no, that's ground. Sorry. Sorry. Actually, I could probably run the grounds over here and just connect them up somewhere else. I could do that. So, purple. G2 is blue, green, yellow, orange, red, brown. All right, blue is G2. G2. G1 is what? No, this is not right. Oh, that's confusing because they're both orange. That one and this is orange also. I'm like, what did I do wrong? Okay, that makes sense. Orange goes to R2, and R2 goes to R1. So maybe I did that one wrong because I already marked it. I think I did do that one wrong. R2 goes to R1. Oh, I did it right. It's this R1. And this orange G1 goes to R2, which is the third one. Okay, I did that right. Just making sure. And then we go to G2. G2 is blue. Blue goes to G1. G1 is the first on the top right side. Oops, pin 2, I think that is. People are probably yelling at me, saying you're wrong. You don't know what the hell you're doing. This second one is B1. Why is there nothing on B1? B1 goes to B2, which is red. Oh, it should have been this one. Huh. I only did 4. 1, 2, 3, 4. 1, 2, 3, 4. Did I not do that right? Oh, I'm so confused. B2, red, goes to B1, the second one. Why the hell is it going to the third one? Oh, I did it backwards. That goes. This input and output is confusing. Oh, jeez. All right, so you really need to put this to a second board because this is just way too complicated. I'll pull that off. I'm gonna plug that one in there. I'm gonna plug that one back in there. Okay, there we go. It's red. Red is 1, 2, 3, 4. 1, 2, 3, 4. B2. B2 connects to B1. B1 is the second one. Let me go back and double check I did the other one right. R2 is orange. R2 is orange. R2 connects to R1. R1 is the first one. Yellow. B1. All right, B1's the second one. It's yellow. B1 connects to G2. G2 is right, the third one. Yellow. Number 3. Well, 1, 2, 3, 4, 5, 6. Whatever. However you wanna do it. To me, that's right so far, and I will double check everything one more time when I'm done. And you know, the problem is, it'd be great if I had colors that were all unique and striped. And if I pin these one out, I would make those all striped so I know they go back and forth. All right, we're up to this wire here. which is, well, we know A, C, clock, and OE all go to the ESP. Green is ground, another ground. Yellow is B, another ground. R is lat. Lat has to go to the, and brown is a ground. So we'll pull those apart right there. And these three can go over here. I mean, these are grounds, right? I can connect all the grounds together, right? Well, I guess I'll just pull them all apart. All these grounds are going to have to go together. Do I need to connect these grounds over here? Do I? I don't think so. So the only one I'm keeping is the yellow. Now I don't know which one is in order. Yeah, yellow. Yellow. Yellow is B. Yellow goes over here. Oh, I could have kept them together. They're all ground. Stupid. Oh well. I didn't need to strip all those. They're all grounds. They all need to go to ground. I should have just kept them all together. These are all ground except for the red. Might as well just pull them all apart. What's the point? I think that's it. So I should have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 cables across. I should have 1, 2, 3, 4. Purple, orange, green. 1, 2, 3, 4 grounds. Where'd that red come from? Red is lat and B. Okay, that makes sense. All right, now I'll go ahead and separate these out. Brown. Where's brown? There's brown. All right, so these are all grounds. We'll twist those together. Those are all grounds. Now I'm going to start wiring this to the ESP. Alright, so here we go. We're going to do, luckily all these colors are pretty much different except for these two reds, but there are two different reds. Okay, so let's, should we go in order so we can organize it? Right? Did they put them in order? No, not really. D0. D0 is lat, which is yellow, red. Sorry. D0 is red. D1 is A. I didn't write down what the color was. Oh, I swear to God. Ah, jeez. Brown, black, white, gray. All right, here we go. Back, here we go back. Start again. Forget I just did that. All right. So, A, D1 is A. A is brown. D2 is, I might have to unplug some of these to program it because some of them don't let you program it. I could always pull it out of the board. That'll be good. I could pull this, I could program a different one and put it in here. All right. What are we up to? D2? D2 is B. B is yellow. Bring the yellow over here. Boom, there you go. Should I twist that around like that? Will that work out better? These are going to have to come over here. Yeah, that'll work better. Bring that yellow around like that. Oop. Get on there. There we go. All right, D3 is E. Oh, these two don't get used. So D4 is OE, which is gray. D4 is gray. D5 is clock, which is white. They always put the clocks and the enables together. What are we up to now? D4. Oops, not gray was right, and then D5 is over here, not D6. D5. D5 is clock, which is what? Right? Yeah. D6 is D. D7 is R1, so that's the red one over here. That goes on D7. And black one is the last one. Should be C. Yes, C goes to D8. I'm going to pull that back a little bit. D8. So is that A, B, and C? Yeah. Okay. All right, so my ESP is wired up. I don't know how to test this before I plug it up. Should I check to make sure there's nothing? I guess I could pin out each one to ground and make sure nothing's touching ground. That would be good. Let's go over this one more time. D0 let red right. D1 is A is brown. B, D, let's just go in order. C is black. D8. OE, gray. D4. Clock. D5. White. D5. R1. D7. R1 is red. 1. D7. And that's red that goes up to... Let me pull that out. I'm going to bring that around and redo it so it's not twisted in there. There we go. That's a little bit better. Yeah, that's pretty in order. Yeah, that should be good. Nothing's twisted up. So that was I right there? R, D7, red 1, D7. That red should be pin number 1. I'm pretty sure. And then we're going to double check this as well. Orange is G1. G1 goes to R2. So this wire goes to R2, which is the third one down. Third pin down on the left. Okay. Yellow is B1. B1 connects to G2. G2 is on the right, number 3 on the right. Orange. Orange is R2. R2 connects to R1. R1 is number 1. Number 1. And red again. Red is B2. B2 connects to B1. B1 is number 2. Red goes to second position left. And then G2. This next one is on the next side is blue. Blue is G2. G2 goes to G1. G1 is the first on the right side. Okay. And G1 is, I did already do that one. G1 orange. G1 goes to R2. R2 is number 3. Yeah. So, and the only pins that should be connected are 1, 2, 3, 1, 2, 3, 4, 5, and 6. 1, 2, 3. 1, 2, 3, 5, 6. Why not 1, 2, 3, 4, 5, 6? Why not 7? Why is 7 not connected? 7 should be connected, right? B2 to B1. Oh no, there's no B2 on this side. B2 goes to no connect. Okay. Jeez. So yeah, I did a pretty good job of double checking everything. In fact, I found a problem that might have been a problem, and it wasn't a problem because there's no connection on that one, that pair. And these should all be grounds. And in fact, I can test that pretty easily. In fact, I'm gonna probably need something to put this on top of something so that it's not. Maybe if I drop this down a bit. I think I'm going to do that. Yeah, that'll work. All right, I think we're good. I got to figure out how to get power onto this thing. Alright, so let me see if I have a connector that'll fit on these kinds of terminals. Oh yeah. Problem is I need to use the middle too. That might work. I wonder if these will slot into the actual proper connector. I wonder if this is this. How do these come out? Apparently these don't come out of these connectors. What? You have to use a retraction pin off the back, don't you? Yeah, there's like a tube that goes in. I have one at work. I wonder if I can just plug this on. No, I'll have to get rid of this connector right here. See if this will work. I'll just go ahead and cut that little piece right there off. All right, and that's a connector for a computer supply. I wonder if I could just use that right off a computer supply. Yeah, I doubt it. Stop dilly-dallying, let's just get it done. See, this is the problem I have. Oh, see, good thing I noticed that. Look at that. Look at that. There's something on there. Good thing I was paying attention. Let's get this out of here. We're done with our wiring. We double checked it and triple checked it. I really need to get a new microphone. Been looking on Facebook Marketplace and Craigslist. I think I'm going to get a Blue Yeti used. I think I can get one for like 60 bucks. I think that's a good price. I'm not really sure. I think they go for 100. But I don't know which model it is. I'll have to double check, but this is either a fuse or a resistor. Probably a resistor or an inline PTC. Yeah, it's a 4 amp. How should I just leave that in line? Probably not. Maybe. Might be safe to just leave. I should have just left it in there. Maybe I'll just leave that in there. You know? You think this thing's going to pull more than 4 amps? I doubt it. Let's just leave it in there. How about that? How about we just leave it in there? So we'll go in here and get some. We'll just go ahead and put that back on there. We'll use yellow. I wish you could make these hot air stations preheat. But they shut off. I might have to add an override switch to preheat it. I think I'm going to keep that in there. I wish I had some clear. Oh, is that not long enough? Well, we'll just leave that fuse in there. It's a 4 amp fuse. I don't know. You know. If we accidentally short something out, it'll save our asses. So, that'll be that. What gauge do you think this is? 16? No. 18? Do a little bit more. Probably 18, yeah. What should I use for this? I have these. I just got these white ones. Let's try those. I got these Wagos. I guess you're supposed to really use these guys. I guess I could use these guys. I'll use one of these probably. I mean, these are cool, but you gotta use one. You have to use 2 of them per connection. And that's just annoying. Oh, better twist those. So I got a low battery power, low battery warning. I gotta find my connector and plug it up. I'm just gonna put those in there. Those are pretty tight. The cool thing about these is I bet I can just shove a connector up in there. Yeah, see, I have one of these though already wired for banana jacks, so maybe I will use that instead. Because I might need to cut these, probably not big enough. Yeah, those are probably going to go all the way in there. Oop. That's the problem with cutting wires. I don't like cutting stranded wires. I should have tinned them first, but like this is deadly right here, so this is what I do. I sweep it into my thing, and then I'm gonna get one of those vacuum attachments with the straws or whatever. I don't know if you've seen that. I'll probably post it later if you don't know what I'm talking about. But yeah, I just sweep my garbage into here and then I vacuum it out of there. And try not to lose any small parts. So what should I do here? What do we do? Let's twist those back up because they were like nice like that. I like the way they were twisted. Twist those back up, and then we put them in here. And positive is, let's do white. Negative. I hate this. I really need to get a crimper that crimps ferrules on there because I can't stand dealing with connectors like this. What time is it? 6:12. You deal with connectors like this and you get one little wire that comes out and touches, you know, the other one. They're so close together, they don't put any shields between them. All they gotta do is put a little piece of plastic that sticks out, you know? And nobody does. Nobody makes these connectors with a piece of plastic between the two connectors to keep them from crossing when you have stranded wire. And that's why you're really not supposed to do it like this. You're supposed to use a ferrule. But, you know, I don't have ferrules. Alright, so if this is... I guess I need to double check this too. Make sure that these are wire. I never check to make sure these are proper, but I will test that now because I don't trust these. And always keep some leads right here, and we'll do negative and got the sun current. Oh. Oops, I have my multimeter set up for current. Alright. Positive, negative, positive. Hope that's not moving the camera. Shit. In fact, I'll just use those for power. Oh, I can't use those for power. Whatever. Alright, so this goes on here like positive, negative, positive, negative. Just like that. Bring that back into view. That goes like that. Alright, and these grounds all need to be tested. I'm going to test these grounds. We're just going to do thorough tests on everything before we plug it up. Because, I mean, not that this is expensive. I didn't get it for expensive. It wasn't a lot of money. I didn't pay a lot for it, but I don't want to blow it up before I even get the test code. Alright, so I don't know if I'm going to do continuity or ohms range. need something to hold my probes. Actually, I print something to hold my probes and I didn't install it yet. A little probe holder somebody made on Thingiverse. Alright. Shrouded to non-shrouded. Actually, let's do the opposite. Let's do ground to ground. We'll do ground to ground. And then we'll put whatever. Whatever. I don't know why it reverses like that. Oh, okay, I see why. Alright, I'm getting, well that's kind of high. I'm getting 0.6 ohms, which is probably the leads. Yep. Alright, all those pin out to ground. Let's do the rest of these. Nope. I don't know why it does that. I gotta fix this. Oh, shoot. Get back in there. I don't know if this back probe adapter is actually fitting in there. Let's go ahead and pull this guy. I better plug up my phone because it's gonna die. Still in business. Still in business. Still in business. Alright, where was I? We're gonna check all these for continuity with ground, make sure there's no shorts. I don't know why it picks up. Sometimes it does that. See that? If anybody knows why, I think because it pulls a negative. It sees a negative voltage and it thinks it's a continuity. I don't know what the deal is there. It's some kind of filter that's not working. This multimeter. See, it shouldn't beep at all. Unless I have the sensitivity dropped too low because I was messing with it. See? It should not be beeping. It says negative 0.000001. I don't know what the deal is with this. Instec GDM 8251A. If someone knows what the hell the deal is with that, I would love to know, but I don't think a lot of people have this multimeter. I should have just got a Keithley. But man, these things are expensive now all of a sudden. I should have bought one 2 years ago. They were cheap. And now they are really, all test equipment on eBay is extremely expensive now. It's crazy. I think everything's good. I mean, all I need to do now is test ground to ground. All right. So ground is ground. You know, so we're good there. And I'm not getting any shorts on any of the, what about these pins over here? Ground, ground, ground. Oh, that's the wrong one. See? Why is it doing an inductive charge there? What if I turn filtering off? Filters should not be running on continuity. Maybe that's what the problem is. No, still works. Still does it. Maybe if maybe I need to start using electrostatic mat. But I noticed, I've noticed this in all situations. I don't know what the deal is there. Ground. All right, I feel safe that ground's ground. Nothing's shorted to ground. Test the ground to power. If I put it on, where we go, 2-wire to power. 3.7 mega ohms. Sounds good to me. Sounds good to me. Of course, I'll boot this up with current limiting, of course. And I think we're good to go. I mean, what I'm just using here is these back probes. These back probe adapters, and I have these BNC shrouded that I just stick, you know, different things on. I just keep these on my bench, and I can plug these in, or you know, like micro hooks or whatever. And so I usually keep a pair of banana jacks just, you know, on my bench. In fact, I have nice long ones that I'm going to have permanently attached to my bench. These are just short ones that run across. I'm going to have permanent ones that hang and I can patch to different things. So they're not just running across all over the place like this. So that's that. I think we're in good position right here. I gotta hook all these grounds up, and then I think we're gonna be ready to power this up. Pull these out and plug this guy back in. You know, I'm gonna program this without it plugged in because we're connecting some IOs that might be in use. And I'm just going to connect all these to ground right here. So we'll just do it ground, 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 ground. These should be signal grounds, not power grounds, right? Yeah, those should all be signal grounds, so I shouldn't have to worry about. Yeah, I'm not going to worry about it. All right. Here's our power leads. We got positive and negative. We got positive white to positive, positive to positive. Go ahead and turn on our power supply. We'll go to... Well, shoot. I don't know what these panels run on. They run on 5 volts. This says VBAT 5V. And I think this had, how many batteries did this? It's got to be 5 volts, right? It's not 12. It's got to be 5 volts, right? What should I put this on? 200 milliamps, 500 milliamps. Let's go with 3. 300 can't fry nothing. That's pretty safe. All right. All right, we're pulling 30 milliamps. Channel 2. 33 milliamps. That must be the standby. Okay, that sounds okay. Sounds okay. I'm gonna pull this USB. I don't know if this is a program since I got a really long cable on it. Plug this guy in. Turn them on. Is he on? Alright, so do I have this? I don't even know if I have the library installed. Install pxmatrix by Dominic. Yes. Alright, it's good. It's in platform IO, so I can just pull it right in. Download. That's a big library. Come on. Examples, pxmatrix, pattern test. Yeah. Examples, docs. Docs are in Chinese. P6, 1/8 or 1/16. Display structures. Configure the library for your panel. The first one is a basic row scanning layout. Call 4, 8, 16, or 32. It's probably 16. Your panel may not handle binary row multiplexing by itself, but we need to handle it in the library. Select row straight. The number of required address lines in the construction depends on the row scan pattern and the multiplex pattern. For example, 1/4 scan display with scan pattern binary require AB, where straight display will require ABCD. What do we have? We only have ABC. Right? Yeah, there is no D. So what does that mean? I'm going to load it up and see. That's all it says. I mean, I'm assuming this is the default pinout. That's why they put it on here. And I don't need to change any code. I mean, I don't think I would. I don't know what it's set up for, but I have a P6 display, which is probably 1/8 or 1/16. I don't know what that means. All right, well, let's just run this and see what happens. I mean, it's got these defines in here, but 16, A is 5. Yeah, I mean, this is all right. It all matches what I got set up. So is this what is this? I don't even know what this is. 32 by 16, right? Yeah, 32 by 16. PLAT POA ABC. Hell, I'm gonna do it. I'm just gonna upload it. Boom, there we go. Let's just upload it. Let's just do it. Is this thing even on? Is this thing even on? It's not even lit up. What's going on here? Unexpected up initializer. Before display updater. What? Shit won't even compile. Well, that's not good. It's not good at all. Why won't this compile? Unexpected initializer before display updater. If def. What? What are you talking about? Let me see if this is the latest version of this library. Sometimes Platform IO doesn't have the latest version. So I'm going to overwrite it. And it's not working. Pattern test example will not compile. Shit. All right, let me stop this and figure out what's going on here. So let's start up the serial console. Go ahead and reboot it. It says hello. All right, seems to be working. Pattern test. All right, so plug it up and see what happens. Turn it off. I'll look at that later and see what the hell exactly which line it was. There could be an invisible character or something stupid going on. Actually, I don't like to plug that in when I boot up my power supply. What do I have the limit on? 300 milliamps. That should be okay. I mean, it's pulling 33. Plug that guy in right there. The only problem I can think is I have this NeoPixel tied to one of the IOs. It might pull it down. Alright, so the bad news is we're upside down. Oh, that's going to make debugging a little hard, but it seems to be working. It's doing 1 in 8, it looks like. I think that's right. 1 in 8. And then it stopped. So it's only doing a pattern test. Shouldn't it print better? That looks about right. I mean, that seems to be what this is doing. Why is it not displaying text, though? That's what I don't understand. Why is it not displaying? Let's do this other, we'll run this other example and see what it does. Oh, see? It's going to flush the buffer and TX2 out. Well, that's not good, but, I mean, obviously it's just going to buffer the data, however it wants to buffer it. It looks like it's flashing the OE. Alright, so this is a pixel test, I guess? Alright, so I'm going to flip this around and unplug this and unplug this. Pop that through there. Put that on there. Put that on there. I don't want to have that powered up before I do anything. And then hit the switch. And why does it go backwards? That's what I don't understand. Alright, so we're working. I guess I could just go ahead and start using it. why is it not displaying display? What does that mean? I don't even know how to use this library. I don't even know what it's doing. Huh. Display begin 4. Where X equals scanning layout. What does that mean? So can I just change it to whatever? Begin 4, begin 16? Is that what I do? There we go. Let's see what the pattern looked right, but it must have been wrong. So let's see what this does. It's only pulling like 30 milliamps. So, I mean, that gives you an idea about, you know, people tell you, oh, full brightness is going to pull 5 amps. It's not going to pull 5 amps. See, that doesn't seem right. Why is it jumping around like that? This is a display test pixel. Why is it doing that? What? That doesn't seem like it's testing it right. Does that look like a valid test? It's all over the place. Maybe the colors are wrong? I don't know what that's supposed to be testing, but it doesn't look right. Yeah, that's it's weird. It's very weird. So if I go back to test pattern, run it. See, I don't even know what it's supposed to be doing because it doesn't even say in the documentation what these tests are. So I'm assuming this is right. I don't really know. For 8-row test. See, that looks wrong. Why is that? Why is the colors all wrong? It was right when I had it on an 1/8. But the pixel test wouldn't work. So I'm a little confused now as to why this isn't working right. Yeah, that's not right. Let's try an 8. Let's try an 8. Why is it defaulted to 4? I don't think this is a 4. But it might be an 8. It's a P6, and it says P6 1/8 or 1/16, but it's not a 32 by 32. It's a 32 by 16. So it's half, fourth, or eighth. But I would think if it was wrong, this string wouldn't have shown up at all. And it did. So now it's right. I think this is, maybe it was just wrong. It seems to do the same. This pattern fails on the scan. Well, that's interesting. So I had it on 4 and 8, and this pattern passes both. So that's a bad test to use. Let me go in the folder and look in the examples folder. I mean in the doc folder. There's a well, that's wrong. It's either 4 or 8. Alright, I'm just gonna try begin 16. Yeah, this doesn't make any sense to me. I don't really understand what it's supposed to be doing. So, what if I, let me just try the, I should be putting water on my cutting board. Gonna warp it. Look, it works! Pixel time! It looks right! I don't know what that's supposed to be. Clouds? Yeah, it's clouds. What is going on here? Why is that working? Lightning? Snow? Wind, I guess? Sun? Moon? Let me turn the serial port on because this example seems to be the real test. Pixel draw latency in US, 100 microseconds, 115 display update latency in microseconds, 372. Draw test with fast update. All right, so it looks like it's working. This panel seems to be 1/8 scan pattern. I don't know if that's as bright as it gets. I can't seem to get it any brighter unless it runs at a higher voltage. I have another one right here. See how bright this one gets. Pretty bright. About the same though. So next thing I gotta do is chain these two together and have a nice big display. That'd be nice. For $13 each. Plus parts. Plus you know, ESP and all that. Yeah. So I figured out what this sketch is doing. I still haven't figured out why the example sketch, the pattern test, doesn't print properly. It doesn't print anything. It just does a test. And I also don't know what the other tests are supposed to do. But I figured out what this test, this example is supposed to do. It fades it up in brightness. I don't know if you can catch that. We'll go ahead and hide that. I gotta turn off that stupid NeoPixel. What pin is that on? I don't know if I can shut that off. We'll hide that under here. Maybe I can just put something over that. Where's the here you go, a little piece of heat shrink. Just stick it right over there. There you go. Done. Alright. So you can probably see that pretty good. Other than the graphics that tests that your red, green, and blue is working, and that your dithered, well, your kind of gradient is working, and your colors, your icons and stuff, that's like yellow, that's blue. It looks like that has a little red in the middle. I don't know if that was supposed to be like that. But I'll restart it now. See, it fades up in brightness It's real fast. Make it a little slower would be obvious. And then it runs it at a different speed. We'll see. See, I want to. I don't know. I think that's phosphor glowing. See, look at that. You see that? It's not phosphor. It's some kind of leakage. See? Can you see the XY leakage? I don't know why it does that. Maybe it needs some filtering. Oops, shoot. Maybe it needs some filtering. Maybe my power is not so clean. Maybe my voltage isn't bright enough. Let's drop it down to 4 volts, 2.6 volts, 2.3. Seems to run on 3.3 volts and higher. So you can run this thing off of 3.3 volts or 3 volts, 2 AA batteries. And it's only pulling 50 milliamps, 30 milliamps at 3 volts. So I don't know if this display is different than other people's display because of the way it was made to be portable. But it's running off of 3 volts right now. 3 volts, 40 milliamps. That's 3.3, 3.4, 3.5, 3.6. At 3.3 volts, it's pulling 50 milliamps. And at 4 volts, 4.3, it's pulling 50. It's pulling a little bit more current, 60. And at 5 volts, it's pulling 50 to 60 milliamps. It's pulling a little bit more current. But not a lot. So you can actually run this panel at 3.3 volts, which is crazy. I don't know if this is going to be bright enough. It's probably bright enough for a clock. Yeah, look at that. Look at that green. Ain't that bizarre? Does that bleed through the shift registers, or is that something to do with the refresh? Because this one doesn't. Yeah, this one does it too. Look. See, all this is lit up. So I gotta see if it's refreshing or if it's doing a static buffer right there. It's only some rows that seem to do it. And that one right there. Huh. Yes, I don't know what the deal is with. Oh, the middle is white. That's cool. Yeah, I don't know what that's about. It might be perfectly normal for these displays to have that. Or it could have something to do with the refresh rate, the scan rate. Because in order to do this gradient right here, these displays just have full on or off for each color. And I don't know if they're mixing, like this is pure green, so they're not mixing other colors in. So this is, I don't know how fast this display is updating, but it has to be updating in, you know, at a pretty good rate. I don't think it's displaying. It says display update latency, but I don't know if that's which test that is. I think that's just a pixel test. I think that's just this test. It's 113 microseconds and fast update 57. I don't know what the difference is. It says in here that it does something to do with the where is it? No, I lost it. I lost the file. There it is. Oh, no, that's the wrong library. Where the hell did it go? I lost it. Something to do with the brightness. The show time is the brightness. So it's probably like a duty cycle. It's UN 16. I don't know what that means. Is it millis? Is it show time? There's no documentation or comments in this code, so I don't really know what that means. SPI transfer latency. It says SPI, but I don't see it using SPI. It says digital write latch pin OE, digital write latch pin low. Oh, here we go. The double buffer. SPI write bytes while micros less than start time. Okay, well, micros minus start time is less than show time, so it's microseconds. And it's using delay microseconds 1, digital write OE. Okay, so it's pushing data and then latching it. This will clock data into the display while the outputs are still latched on. That's why we're getting this ghosting, probably. I think that's why you get this ghosting, because the way this works is it latches the output while it buffers the data to it. It doesn't try to cycle the latch. I think it's called a latch or output enable or whatever it is. It doesn't latch because then the display would flicker. So what it does is it does a full buffer rewrite, from what I understand. I could be totally wrong on this. I haven't read anything about this. But I did read some article, PDF or something that said, there's no PWM or control on these pixels. It's if you want it to fade or dither or have a different brightness, or you want to mix colors, you need to set it like that. You need to kind of like send pieces that blend together to make that animation or that those colors fade into each other. I mean, you can do mixing, color mixing, but if you want to do a little bit of red and a lot of blue to do a purple, you can't just mix those two colors how you want to, like you would with a NeoPixel. You have to send it frames so that the red on time and the blue on time is not the same. You know what I'm saying? So that's how that works. That's my understanding of it. I'm sure it's a lot more complex with, as far as how you mix the colors and how you do that. And I haven't looked at this code at all. But it's probably real quick in here. Let's see. I don't even know if this is doing that. There might be more advanced. Yeah, it looks like it's doing some kind of combination of colors, and then it is setting some kind of offsets and fill matrix buffer XY selected buffer. This does all the logic for how it fills the buffer, and for different patterns of how it reads it out. So it looks like it's filling the buffer in the order of the SPI data out. So it's just shifting the data straight out, but it's filling the buffer in the proper order for the display. Whether it does, what kind of interlacing it does, half row, offset, and all that stuff. Because these displays are all different the way they do that. Color interlacing, yeah. So they're doing color interlacing to interlace the colors. So normally you interlace your rows, to get your refresh and animation. This isn't doing any animation, but they're also interlacing the colors to get the color, that you want. So like these gradients are interlacing off and on. In each one is a different, I guess, ratio maybe. So I think you've been in the dark long enough. That's so pretty. Look at that. Ooh. All right, I think I'm gonna actually do something with this now and get some actual data on here, since it should use the Adafruit graphics library and I'm fairly familiar with it. So let's get to tinkering and write some actual code for this puppy. And now that I know it works, I can start building a board that just plugs right in the bottom and gets rid of all these wires. So let's see what we got. Alright, so looks like all we need to do is call. Let me figure out why this other example doesn't work. That'll be a good way to figure out how this to learn how this works. Alright, I got some more whiskey. So now I can actually start coding. This is Amador. I think it's whiskey that's aged in wine barrels, I believe. That's really good. What do we want to do? Well, I guess we could see what's already out there. Let's first figure out why this example doesn't work. This example says, pattern test example, says display updater, display test pattern 70, display ticker attached. So if I take the ticker out, right, so I don't want to do the pattern test. I just want to do, well, let's do the pattern test to make sure it's working. Display updater. Oh, I see what's going on here. This is it's so simple but so stupid. Oh, so the display updater is a process that runs light up LEDs and hold for showtime microseconds. So it's like a persistence of vision. The longer you have a showtime, the brighter it looks, I guess. So let's just try this. Let's try that and see what happens. Pattern test. I'm going to change the display updater to test pattern to display 70. And then I'm going to upload it, and it should work properly now. I was wondering why it wasn't showing pixel when it's in there, and it's because there's no chance for it to ever show pixel, because the display updater is not running separately. Why? I don't even know why that's in the code. I guess I'll update it and push a PR and do a toggle define. There you go. Pixel 70. So 70 is the persistence. If I want to dim it, then I change the display. I think you can change the brightness too. But I don't really understand what the difference is, the show time and the brightness. So that, I need to figure that out. Like I said, there's no documentation on this library, and I don't know which parts of it are inherited from the Adafruit graphics library. So I need to just read over the H file here and see. Yeah, so there's a set brightness. I don't know what the default is. Let's find out. Brightness equals brightness underscore brightness is the default. Default brightness is 255. If fast update and brightness equals 255. Else double buffer if defined double buffer, and if else else latch. So showtime. I don't know what your options for showtime is. This will clock data into the display while the outputs are still latched. We therefore utilize SPI transfer latency as LED on time and can reduce the waiting time, showtime. This is rather timing sensitive and may lead to flicker, however promises reduced update times and increased brightness. I don't know how that increases the brightness, but faster refresh times is good because we're on ESP8266, but it's also bad because you can also have more flicker. But the faster you can update the display, the better your odds of not interrupting the Wi-Fi interrupts and dealing with that whole thing. Set fast update false. Display draw time 15, display draw time 0. Why would the display draw time be 0? Let's find out. Why would you have this as 0? I don't understand that. Let's just find out what happens. I really don't get it. I'm going to run OBS so I can see what's going on over here. Well, have a look over there. Alright, so okay, so it's basically dark, right? Okay, so what happens if it's 255? Is that going to make it brighter, or is it just going to make it slower? I love the way the pixels start lighting up. We've got to find a way to blank that. I think the pinout for this might be non-optimal. For uploading. I might have to find a way to blank it. Alright, so look how bright that is. That's 120 milliamps. Holy shit, that gets bright. Look at that. Wow. I didn't know it could get that bright, so that's really cool. So can I get even brighter? I mean, all right. So that's a show time of 255. I don't. And is fast update on or off? I don't know. Fast update helps it to reduce display update latency on larger displays. It probably doesn't make a difference. Oh, Just had an exception. Just reset. Exception 29. Okay, see, so the show time's higher, but there's a noticeable flicker. You see the flicker? I don't know if you can see it on the camera. There's a noticeable flicker. Yeah, I don't think any of that works. But there's a noticeable flicker. Let's try fast update. And see, look, it crashes. There must be a loop in here that's... or it's running out of memory. Huh. Let's, this is interesting. Let's try 254. Because it didn't do it before, so maybe it has something to do with... No, that doesn't make any sense because it's updating less, so the buffer can't be filling up faster. Let's try this and see what happens. We're going to do 254. Maybe there's some kind of overflow. 255. Maybe it's one off. Oh, or maybe we're suspending interrupts too long. If that's the case, then there should be a clamp in here that we're going to wait for a refresh or a crash. I bet it doesn't crash. We're going to go to here. We're going to check this fast update true. Draw time 15. Update enable true. Display update enable. What does that mean? And there it goes. Alright, so something's wrong with this library. I probably need to do a dump on this to find out what. Although I am not running... I'm not running... I don't even know what version this is. I'm pretty sure I'm not running ESP staging on this. Let's try, let's go full Monty. Let's do full white. And we'll do 554, and we're gonna do fast update. Let's try that. I hope you can see this. Yeah, and it's not too dark. Let me go ahead and focus it though. That'll help. Whoo, that's bright. Look at that. 270 milliamps. 5 volts. Alright. Let's see if it crashes. And this is fast update too. So yeah, I can see it pulsing. Probably can't see that on the camera. Yeah, maybe you can. See that? It's kind of like pulsing. If I had a 4K, maybe I don't have 4K turned on. It uses way too much space. But it seems to be working. Yep, never crashed. It's just crashing. I don't know why. What was that? Well, that is quite interesting. Let's do something easier. Let's go into loop. We'll do the display. Print. And it's confusing when you do display.display. I always choose to do a, like panel or px. That would make more sense because it's just confusing to newbies. I mean, it's really. I wouldn't have had this working for another week and a half probably, if I had to figure out how this display functioned. If the work wasn't already done and the people haven't already figured it out. It just so happens that this display is fairly standard layout. So it was just causing a problem using a display of 254. So I don't know what the max is. But this also isn't updating. So let's it's not even updating. Why is it not updating? Is it because it's too many? It should be updating and it's not. Okay. So what's going on here? Do I need to set the cursor every time? Do I need to clear the display? How do I, I'm assuming this is buffered. So I'm assuming I have to clear display. So if I do display dot clear buffer or clear display? The problem is this is a, so you have to clear the buffer. That's pretty much guaranteed. That's what that means. Clear the buffer. I'm going to leave the light on. I mean, I guess I could turn the light off. Yeah, that looks really cool. Look at that. It's over there. So look, it blocked it all out. See what's going on here? This is what happens if you don't clear your display. So you got a clear display. I think that's how you do it. I'm not really sure. There we go. All right. So there we go. Let's drop this down to 10 microseconds and see if we get a better. All right, there we go. So now I can rate it FPS mode. There we go. Milliseconds. Chooching away. All right, I don't need to be outputting this anymore. Clearly. And I can probably just take out the delay entirely and just do, let's do 5 milliseconds. I mean, why not? All right, let's try this. Here as we go. 80 now. All right. Look how fast it's going. You can't even read those 2 digits. You can see those green pixels though. They sure show up real good on the camera. You don't really see them that much. You see a little glow. If you squint, you don't see them at all. If you had a filter, you wouldn't see them at all. I wonder if that's like a crosstalk of some sort. Or it just bleeds through the shift registers. Oh, not too shabby. Let's turn the camera back on. I mean the light. Turn the light back on. Woo! Sorry to blind you. Yeah. I don't know if I have a film of some sort that I can put over this. What if I make this like random color? That'd be pretty cool. Alright, let's see what we can do here. Let's make this a nice purple color. Let's try that. What's a good purple? Let's see purple. Who wants to see purple? RGB colors. Yeah, here we go. Nice purple. What's a good purple? 127, 255. That's a good one. Let's try this one. And then we'll change this to something better, like an FPS. We'll do a FPS meter. That's a nice purple. I like that. That's cool. It could probably be a lot brighter. Let's double this to let's set 70. I don't know why it's oh man, where'd my whiskey go? I think that works. This way I can see it from the way I see it. Hey, there we go. Look at that. It's awesome. So it's a lot brighter now. You can absolutely see it. I just don't know what to do now. Yeah. Right? You know what I'm saying? Yeah. So, still going at it. Getting a little tired. So the idea is I should be able to use any Arduino graphics library right? Oops. That's my understanding, is I should be able to use any... Sorry about my printer noise. I'm printing out a test cube for this white pit film I just bought. It seems to be under extruding compared to what I'm used to, so I don't really know what's going on there. It compiled, that's good, so let's we're gonna run this and see if any of these fucking run. Because I mean, this should be fully compatible with GFX library. I should be able to use any examples. And I should be able to use any code I already have that's for other LCDs. I mean, the resolution's not as good, but it should still work just fine. It knows the height. I can use fonts. So we'll upload that. And, ooh, it did something. It did the lines. It's doing the demos, but they're not working right. It's they're just they're not displaying properly. Yeah, see, there's some adjustments you're gonna have to make to some stuff because the way it works is a little different. I don't know if you can fix that. You know? And I made the mistake of using a monochrome display first of all to do this. I need to pick the ST77 whatever. So you see it, it's running. Yeah, it's doing it. It's just going way too fast. And I don't know why. So the question is, how do I make this work? How do I... let me figure out how to make it work, and then I'll change it to a colored example. So we're doing One that clearly works is, what's the first one? Draw pixel white, display showtime, test draw line, test draw rect, test draw circle. We saw that. We saw that work. Delay 1. So that's what's curious, is why... Okay, I see what the problem is here. When you call display, it only displays one frame. The reason we run a ticker on this library is because it has to run constantly to update the display. It doesn't do it in the background. The ticker, that should be built into the library. There might be a reason it's not. It might be a problem. It might not give the user enough control over their ISR routines. But it'd be really cool if we can just use this like the normal graphics library and just call display, and whatever's in the buffer gets sent to the display continuously. And maybe have a start and stop and a control to enable it or disable it. Problem is, I don't think there's any control in the library. I think you have to do it in your user code, which means we have to change some stuff a little bit. So basically we need to come up here in setup. We move the ticker before the test. And we change this to showtime. And then we go in here and we take all the displays. Display, showtime. Control G, and then we comment them out. So now the timer's running. Okay, so this should work. I don't make any promises, but this should work. This should be the Adafruit GFX demos for the SD1306 on a panel, and eventually I'll change this to a color one. They need, all their samples are different. It'd be nice if somebody went and I have copies of the code somewhere, but I haven't had time to go in and... We got a print just came off the printer. And what's interesting about this PLA I just bought, this decal, I think it's called decal. Hey, there you go. That's what I'm talking about. Ooh, that's bright. Yeah, it's going real slow though. I don't know. Yeah, that's weird. Anyway, so let's try this again. There we go. I don't know why that's yellow. It's kind of strange. Oh, I know why it's yellow, because I am overshooting my current limit. Let's hit 400. There we go. And shit, that's even higher than 400. Let's do 500. Let's do, there we go, 600 milliamps. Restart it. Oh shit, I'm still clipping. How much current is this pulling? Let's do 800 milliamps. No, still current limiting. Let's do 1 amp. Looks like if you do pull white, you will hit a couple. There we go. It's just about. It's a little bit over. Let's do 1.5 amps. And let's restart it. All right. Whew, that is bright. Wow. I don't know if you can see that. Yeah, there you go. That's much better. All right. So, I guess because the display is so small, it doesn't really do what you expect it to do. Yeah, I mean, normally these are animated, but I mean, I don't really know what's going to happen on this tiny display. You're talking about a 128 by 64 display. This is a 32 by 16. You should still be able to get some kind of animation going. I don't know what this is displaying. This is test draw fill rec. That must be because the font size is not getting set back. So let me see. Set text size 1. Set text size 2. Let me set the text size back after I am done writing dead beef. In fact, let me take that out completely. Well, we'll just update it real quick, and then I'll start switching this over to some better demos. But I just want to get an idea about what the differences are. They should be well documented, and they're not. So I don't. Before I make major changes, I need to know what the hell's going on. And I need to make an FPS meter and find out. See, that should animate. I don't know why it's not. It's probably because the delay in the animation is less than the timer. So let me set a define for that. Define animation speed. 5. Oops. 5. And then we'll go down here and we'll find all the these delay ones. We will change them all to anim speed. And let's try that. I don't know what the ticker is set to. 0.002, is that 2 milliseconds? That's not a lot. That's what, that's only 2 milliseconds. What is? I don't even know what that is. Is that 15 frames a second? I have to think about it. No, see, it's still not working right. Let's see what this ticker is. I don't remember what the ticker library does. Delay milliseconds between each frame. So if it's a factor of 10 or a factor of 5, well, we'll see what we make it. We'll try this and see what happens. I don't know what SPI frequency we're running at. 400. That animation works fine. Why the squares doesn't work, I don't know. See that? I saw that. Did you see it? It ran. sometimes you just want to play with stuff and not freaking read docs. I read docs all day long. On my weekend and when I'm playing with stuff, I don't really want to read docs right now. It gives me a headache. I didn't see any difference in that animation right there. It seemed to be exactly the same. I have a feel that your frame rate needs to be calculated based on your show time. So maybe we can add a helper function to get the frame rate and just calculate it automatically. And you say, you tell it what your desired frame rate is, and it can calculate, what it needs to do. Because I'm not seeing this. For some reason my fan doesn't turn off after I print a job. It's very annoying. So let's figure out why. I mean, the test draw line seems to work fine. So, delay 250. Okay, so let's set the animation speed to 250. Maybe we're just going way too fast. I mean, 30 frames a second. We might need to... That makes sense. It's this timing is set up for running on a high resolution display, so it's drawing 20 lines, and you have time to see that. This is only drawing 4 or 5 lines. You're not going to see it. It's going to happen in a blink of an eye. So you probably have to scale that by 5 or 10. I mean, I'll have to look and see what it gets to, but these animations are tuned for a much larger display. Well, higher resolution. There we go. See, that's what I'm talking about. That animation works fine because there's a lot of lines, but the other ones don't because there's a lot less. So, I mean, if I was... There we go. Look, it's animating. So, that might be a little too slow. But it's finally working. So, there we go. We got Adafruit SD1306 animations running on a... That one didn't work because it only had 2 triangles. That's the character map. That's Hello World. But the font is enormous, and there's just a millisecond timer. So this is a good demo. I'm gonna save this. I'm probably gonna make it a little bit faster, maybe 150. Let's try that. All right, so scrolling's working. Well, it's text scrolling. I mean, I don't know why that I gotta fix that. That's wrong. That's totally wrong. Apparently, rotation doesn't work on this panel. Yeah, multicolors. Hey, woohoo! Love it. I mean, these colors should be, they should make sense, not just be random, but what are you going to do? This should just be random. Let's make it random color, man. And then this one over here. That's it for now. I'll probably make a follow-up video of what I actually wind up doing with these panels. and maybe some more instructionals. Take care. Till next time.